Hey guys, this video is going to show you how to complete homework number 16. So this homework is dealing with dividing by multi-digit numbers. So they give us an example to start with. A farmer sells milk in crates that hold 18 bottles. She has 612 bottles of milk. How many crates can the farmer fill? So to solve, we have to divide 612 by 18. We're going to use the partial quotients model. So the partial quotients model is something that you're going to hear referred to in your book quite a bit. It's just one way to solve a long division problem. So they start by finding the partial quotients, and then they add them together to get their final answer. So they took 612, they divided by 18, and they started by subtracting 540. And they got that number by taking 18 times 30. So 30 is our first partial quotient. They subtract that from your dividend and you're ending up with 72. Then they subtracted 72 because 18 times 4 is 72. So 30 and 4 are our partial quotients, and we add them together to get 34. The farmer can fill 34 crates. So remember, the first three questions here are just asking about the example. In the example problem, why is the first partial quotient 30 and not 3? So if we take a look here, they did 18 times 30 to get 540. So why didn't they just do 18 times 3 instead? Well, we know that this 54 is in the tens place. And so really, if we'd done 18 times 3, we would have 54 rather than 540. And we want to go as big as we can with our first partial quotient to get as close to the answer as we can in as few steps as possible. So why is the first partial quotient 30 and not 3? The answer is that we want to get as close to 600 as possible. So why is the second partial quotient 4 and not 40? Well, this one is 4 and not 40 because 72 is in our ones place. So we have 72 ones in this case, not 72 tens like we had with our 54 up here. So why is the second partial quotient 4 and not 40? Because we have 72 ones left to divide. How do you use the partial quotients to find the quotient? You add them. Pretty simple. So that's questions 1 through 3. These questions aren't really asking you to do anything except to take a look at the example and really think about it. So you might have different answers other than the ones that I have here, and that's perfectly fine. My biggest tip for dealing with multi-digit dividing is basically to take your divisor and to make a list of multiples. That helps you to come up with your partial quotients much faster. So what I usually do is I do 18 plus another 18 will give me 8 and 8 is 16, 36. And then plus another 18, 8, 9, 10, 11, 12, 13, 14, 4 carry 1, 3, 4, 54. So if you make a list of multiples off to the side of your paper before you even go to do your division problem, it makes it a lot simpler to say, how can I get as close as I can to this 612? Well, if I know that 18 times 1, 2, 3 is 54, then I know I can do 18 times 30 and subtract that 540, and that leaves me with just 72 left. And if I keep going in my multiples of 18, I'll find out that 8, 9, 10, 11, 12, 5, 6, 7, 72 is 18 times 1, 2, 3, 4. So if I could give one tip for solving these types of problems, it would be to do this first. Just make a quick list of multiples of whatever number that you're working with. Go up to 4, go up to 5. You don't really have to go too far. So chances are you probably don't know your multiples of 28 off the top of your head, and that's perfectly fine. There's a simple solution for that. Off the side of my paper, I'm going to list my factors, or my multiples of 28. So I've got 28, and then I can add another 28 and get 56. So that's 28 times 2, plus another 28 gives me 84. That's 28 times 3. Plus another 28 gives me 112. That's 28 times 4. So this is going to help me when I go to do my problem. So I've got 28, 56, 84, 112. So now I'm going to take a look at my problem, and we're trying to see how many times 28 goes into 1,204. Well, I know that 28 times 4 gives me 112, and I know if I add a 0 and do 28 times 40, that will give me 112 plus a 0 in my ones place. So 28 times 40 gives me that number there. I'm going to subtract that from my whole, and 40 is going to be my first partial quotient. 4 minus 0 is 4. 0 minus 2 you can't do, so we change that 0 to a 10. 10 minus 2 is 8. We took that from here, so we are left with 0 and 0, so 84. So now I'm going to look back at my multiples of 28, and I can see that 28 times 3 is 84. So that is my second partial quotient. Minus 84 leaves me with 0. Now I add my partial quotients together, so 40 plus 3. 40 plus 3 gives me 43. So how many cans were collected on average each day? 43 cans. Now remember to label your number. When we're talking about 43, we're not talking about 43 crates or 43 days. We're talking about 43 cans of food in each crate. If I want to double check my answer, I can use multiplication and multiply 43 by 28, and I should get 1,204. All right, so there's number 4. Number 5, Tracy is trying to figure out how many rows of chairs are needed to seat 888 students, with 24 chairs in each row. She writes the equation 24 times blank equals 888. What related division equation could Tracy use? Well, remember that division and multiplication are kind of like opposites. So if I multiply by 24 to get 888, then I have to divide by 24 to get my missing number in my equation. It didn't say to solve it for A, so all you had to write was 888 divided by 24 equals. We don't really know what it equals yet. So how many rows of chairs are needed? So in B, now we have to solve our problem. So 888 divided by 24. So I'm going to go ahead and think 24 times 2 is 48 plus another 24 is 72 plus another 24 brings me to 106. So that's going too far. I'm going to stop at 72. So we'll say 24 times 3 equals 72, but really I want to try and get as close to that 800 as possible. So I'm going to multiply by 30, add that 0. 8 minus 0 is 8. 8 minus 2 is 6. 8 minus 7 is 1. So my first partial quotient was 30. Now I have 168, and I want to see how many times 24 can go into that. Well, let's see. I know that 106 is 24 times 4. So I'm going to go ahead and subtract 106. 8 minus 6 gives me 8, 7, 2. 16 minus 10 gives me 6. Number 6, Ricardo used partial quotients to divide 1,862 by 38, and he got 13. A says, how could Ricardo decide whether his answer is reasonable? Is his answer reasonable? Well, remember that multiplication and division are opposites. So really, if we wanted to know if his question was reasonable, we can ask ourselves, do you think 13 times 38 will give us 1,862? So not really good at multiplying 38 by 13, but I do know that 13 is close to 10. So let's say I took 10 times 38. I would expect my answer to be 380. Is 1,862 even close to 380? Absolutely not. Not even close. So is his answer reasonable? No, it's not. Because if you round 13 down to get an estimate, the answer should be near 380. Is Ricardo's quotient correct? If not, explain and correct his answer. If so, show that he is correct. All right, so it's time to do this problem for ourselves. So I'm gonna do the problem down at the bottom here, and then I'll explain. So I've got 1,862 divided by 38. So let's see. Right away, I'm gonna write off to my side my 38 multiplication multiples. So 38 plus another 38 gives me 76, plus another 38 114. So plus another 38 gives me 152. All right, so let's start there. So 38 times 1, 2, 3, 4 gives me 152. 152. I'm going to put that 0 there. 2 minus 0 is 2. 6 minus 2 is 4. 8 minus 5 is 3. 1 minus 1 is nothing. So now we have 342. All right, so after 342, I'm going to just continue on the next piece of paper. You could do this on scrap paper. They don't often leave enough room on your paper. That's perfectly fine. All right, so now we've got 342, and we want to see, does 38 go into that one? Let's see. I know that 38 times 3 is 114. So we'll do 38 times 3. So 2 minus 4 you can't do, but you can do 12 minus 4 and you get 8. That 4 becomes a 3. 3 minus 1 is 2. 3 minus 1 is 2. So now we're at 228. And I'm just going to keep going. I know that 38 times 1, 2, 3, 4 is 152. 8 minus 2, 8, 7, 6. 12 minus 5, 5, 6, 7, 8, 9, 10, 11, 12, 7. 76. 38 times 2 is 76. All right, so now I have to take my partial quotients and I have to add them together. So 40 plus 3 plus 4 plus 2. 40 plus 3 gives me 43, plus 4 more, 44, 45, 46, 47, 48, 49. He was not correct, but what was his error, do you think? So perhaps, what are some errors that he could have made? Perhaps he added his partial quotients wrong. Perhaps he got his multiplication wrong. There's several different answers that you could have for why he got the wrong answer. One last thing I just want to say about partial quotients is that there's really no wrong way to do them. You might have gotten different partial quotients than I did, but you should still always come up with the same final answer. So let's say that you didn't know how to multiply by 38 and you just kept subtracting 38 and used 38 times 1 off to the side. You can still get the same answer. It would just take you 49 tries to get that answer. You could do 38 times 2 over and over again, 38 times 5 over and over again. At some point, you're going to add up all your partial quotients and you're going to end up with the same answer no matter what. So you may have done 38 times 40 and then 38 times 7 and 38 times 2. That's perfectly fine. Any way you do it, you're going to get the same answer. So partial quotients, your partial quotients might look different than the ones that I've done on here, but they will always add up to the same answer as long as you are getting your multiplication correct and you're adding and subtracting correct. The number one mistake that I see people make when they're doing division like this is that they subtract wrong in their math down here. So always double check your math here to make sure it's correct. Subtraction is sometimes so easy that we tend to rush through it and overlook something.